My talk is about the importance of motor skills for development. People think of motor development as the items on a standard milestone chart. And of course, motor skill development includes basic postural and locomotor milestones, but it's so much more. All behavior is motor behavior. Eating a snack, sitting in a chair, hugging a caregiver, walking, playing with toys, looking, smiling, eating, and speaking. Those are all motor skills. Manual actions, such as grasping and exploring objects, or using artifacts or tools like crayons and spoons, motor skills. And social and communicative actions, like petting a dog or pointing and nodding, pretending to drink from a cup. Those are motor skills. All behavior is motor behavior. So to the extent that behavior is important, motor skills are important, and behavior develops. So motor development is really behavioral development. In fact, motor skills provide an important window into development. Generally, motor development is age-related. So at first, babies can barely get their head out of the carpet, then they can race across the living room floor. Here, age runs along the x-axis. And, age norms are useful diagnostic tools because motor skills are directly observable and anomalies are correlated with developmental disability. But age norms are deceptive because age and motor experience are highly correlated. Older infants are also more experienced. For example, infants' age is correlated with their walking experience. But when age and experience are unconfounded, experience is a better predictor of skill than is age. So infants with more walking experience walk faster. Even at the very same age, walking experience predicts walking skill. That means motor skill acquisition is not a direct readout of neuromuscular maturation. And infants acquire immense amounts of practice. This graph shows the accumulated number of steps per hour plotted against days of walking. Each circle is a different infant's spontaneous walking in a lab playroom that's set up with toys and elevations, and babies walk a lot. The average toddler takes 2,400 steps per hour. That's like 14,000 steps a day. And we see the same thing in a new sample of infants tested in a lab playroom that's set up with different toys and different elevations in a different configuration. And we see the same thing when we record walking in babies' homes. Infants show immense variability in when skills develop and in which skills develop. Long red bars here show the normal range in skill onset ages. There's huge differences between babies in when skills appear. For example, some babies start walking at 10 months and some don't walk till 16 months. There's also widespread variability in the form of each skill. So take crawling on hands and knees. Some children crawl on their hands and knees, but some crawl on their hands and feet. And babies can crawl with their bellies dragging along the floor. They can inchworm crawl with their belly up and down. Children solve the problem of moving in lots of different ways. And some of the ways that babies solve the problem of moving, they're not exactly crawling, they're not exactly sitting, sort of a combination of both, or they're hitching, bum shuffling. Anyway, there's lots of ways of getting around. Another problem with the standard milestone chart is that it perpetuates the idea of a universal series of milestones. But age norms are normed on some sample of people, and that sample depends on the culture and on the caregivers. Caregiving practices affect motor skill acquisition. So you're looking at a film of an infant bath in Mali. And the handling and the holding look rough to Western eyes. But in some cultures, caregivers don't hold their babies like they're a fragile carton of eggs. And it turns out that cross-cultural work and true experiments with random assignment to exercise and to control groups show that exercise accelerates skills like sitting and walking. And there's a dose response effect. That means that the more exercise caregivers give their babies, the earlier our onset ages for skills like sitting and walking, and for skills like head control and postural control. Here you see an Armenian man exercising his infant to promote motor development. In many cultures, vigorous exercise like this is integral to childbearing. It's part of parents' expectations about what you should do, what you need to do to ensure that your child has healthy motor development. Exercise facilitates motor development. Well, constraint delays motor development. All over Central Asia, caregivers bind their infants in a special cradle. They're bound from neck to toe, prevents all movement except in baby's fingers and toes. And although this practice is common in Central Asia is not represented in developmental science. The World Health Organization published standards, not norms, of the ages when infants should sit, should crawl, should stand, and walk. And these standards are based on data from 6 countries, but none of those countries were from Central Asia or from cultures that constrain movements, and none of them are from cultures that exercise or facilitate infants' movements. The red curve here are data from infants in Tajikistan. These are babies who were cradled through most of the first 2 years. And you see substantial delays up to several months, delays relative to cultures like ours that don't constrain movements. But by 20 months of age, all the Tajik infants are displaying all the basic skills. And you don't have to travel to Central Asia to see the effects of restriction. In 1992, the American Academy of Pediatrics started the Back to Sleep campaign. So they told parents to put their babies to sleep on their backs to avoid sudden infant death syndrome. And that led caregivers to encourage less prone time when babies were awake. Restricted prone time had the inadvertent consequence of delays in prone skills. So then the American Academy of Pediatrics had to institute a tummy time campaign. Development of motor skills make behavior more flexible and more functional. Flexibility is necessary, it's not optional, because children have to cope with a variable body in a variable world. I'll give you an example. This is an adjustable drop-off apparatus. So it can have really small drop-offs that are like a step, so it affords locomotion, or really big drop-offs like a cliff where locomotion is impossible. And visual and haptic information are available to tell babies about the relations between their bodies and the environment. So they can get perceptual information from looking and from touching. Experienced crawling infants select their actions adaptively, so they will easily crawl down drop-offs within their ability, but they will not attempt to crawl down drop-offs that are beyond their ability. Even if it's 1 centimeter beyond their ability, they will not crawl down. But what happens in the same age infants who are new walkers? Novice walkers repeatedly attempt to walk down drop-offs that are beyond their abilities. They really do, even at 90 centimeters. Even on a cliff, they'll plunge right over the edge. They behave as if they have no clue about the limits of their own abilities. But 6 months later, after infants have several months of walking experience, again, they select their actions adaptively. Again, they can perceive precisely within 1 centimeter of accuracy whether a drop-off is safe for walking. Experienced 18-month-old walkers look like experienced 12-month-old crawlers. They know precisely whether a drop-off's too high for walking, and if it's too high, they find an alternative strategy. Here's the data. So 0 here represents the largest drop-off that each infant could navigate. So the data are normalized to each infant's ability. The negative numbers are drop-offs that are smaller than the threshold, so they're safe. The positive numbers are drop-offs that are larger than the threshold, so these are risky. And then there's a really easy 1 centimeter drop-off and a 90 centimeter cliff-sized drop-off. This red curve is experienced 12-month-old crawlers. These babies are perfect. They're probability matching. They're matching the probability of attempting to the conditional probability of success. Here in blue, I added the novice walkers. These babies vastly overestimate their abilities. They'll attempt drops that are 9 centimeters too large on 75% of trials. They attempt the 90 centimeter drop off on 50% of trials. This group is the same age as the experienced crawlers. The difference is they had not learned to perceive the relations between their drop-off and their new locomotor posture. Now I've added the 18-month-old experienced walkers in green. They perceive equally well as the experienced crawlers. So babies are coordinating perception and action through experience with that perception action system. Crawling experience teaches babies to perceive possibilities for crawling. Walking experience teaches infants to perceive possibilities for walking. And there's no evidence of transfer from earlier to later developing skills. Longitudinal data show really dramatically that there's no transfer from earlier to later developing perception action systems. This is a typical baby in the first week of crawling, totally clueless, no idea how steep of a slope they can crawl down. After 10 weeks of everyday crawling experience, just crawling around their homes, errors drop to 50%. That means half the time, babies can correctly reject the slope for being too steep and find an alternative way down. By 20 weeks of everyday crawling experience, babies have fast and efficient exploratory movements. They can tell within 2 degrees of slant whether a slope is safe for crawling or not. But then when those same babies stand up upright facing the same slopes, but now as novice walkers, no idea about how steep of a slope they can walk down, and learning has to start all over again. After 10 weeks of walking experience, errors drop again to 50%. There's no evidence that learning is even faster the second time around. Perhaps most important, motor skills lay the foundation for psychological development by instigating cascades of developments that facilitate learning across psychological domains. For example, when crawlers learn to walk, they go more, they see more, and they do more. Walkers go more compared with crawlers. Novice walkers spend way more time in motion than experienced crawlers. Novice walkers take twice as many steps, and novice walkers travel 3 times the distance compared to experienced crawlers. At each week of crawling, babies get faster and faster, but when the same babies stand up and start walking, they're faster from their very first week of walking compared to 21 weeks of crawling. Another consequence of learning to walk is that it alters infants' view of the world. Here's a crawling infant's view of the world. Crawlers see the floor right in front of their own hands. That's what's filling their field of view. Here's what walkers see. When babies are up, the whole room swoops into view. These schematics show the average field of view for crawling compared to walking. While babies are crawling, they see mostly the floor. While they're walking, they can see the whole room. And walkers do more compared to crawlers. These data show the amount of spontaneous carrying in same-aged crawlers and walkers. Walkers carry objects a lot more than crawlers do, even though crawlers also can carry objects. And walkers also visit more distant objects, and they do more with the objects that they access. I want to end with one more example of how motor skills enable learning. These are two 10-year-old girls at a playground, and like they're using this fence to play. It's not even intended as playground equipment. Children use things like playground equipment in ways that were never imagined by their designers. Motor skills capitalize on all the opportunities in the environment. Children generate so much movement. About 10 years ago, I started to document how much children move. Natural activity is more abundant, more creative, more generative than researchers had ever imagined. And movement is social. Activity emerges from and builds on social interactions. One child's activity instigates another child's activity. As researchers, we typically study children one by one, all alone, or maybe they're with their caregiver. But part of the joy of moving is the joy of doing it with a friend. Thanks.